Hello, this is Ul Balis, Professor of Pathology and Bioinformatics at the University of Michigan. In this short demonstration, I will go over the standard workflow of using the Slideless web-based framework with an incorporated tool which we've developed in our lab known as VIPR for vector invariant pattern recognition, which is intended to assist in the demarcation of ground truth maps, so-called segmentation of histology, which is otherwise an extremely lengthy, time-consuming, laborious process, which has the general property of slowing down the pace of discovery by virtue of the immense investment in time that's required on the part of subject matter experts to generate ground truth maps for image analytic development. So in this first example, I will accelerate the tool to some representative images, loading a skin image. Obviously the browser provided by Slideless provides all the standard browsing capabilities, panning, zooming in real time. However, incorporated into this tool are some of the capabilities of the image analytics as developed in our lab at the University of Michigan. As I mentioned earlier, the VIPR tool allows for highly precise pixel level segmentation of unique morphologic features within any given histologic section without the need for extensive training, and often, not always, but often, it is possible to converge on a characteristic morphology with as few as a single vector, which is really a significant departure from what is encountered with traditional machine learning or deep learning techniques that require larger curated sets of entire classes of images. So in this example, for example, here I'll just pick some adjacent nuclei of this epithelial tumor. And the algorithm is designed to operate in the mode that pathologists are comfortable with, which of course is just painting the lesions of interest. Here I've painted 3 adjacent malignant cells. I'll run the algorithm in real time. The mask is loaded, and we can see that the algorithm has identified many, but not all of the lesions of interest. This is simply a sensitivity threshold issue by adjusting slightly the threshold. In short order now, we've, with a single training algorithm, identified a classifier which is finding all the malignant epithelium, and you'll notice it's avoiding the intraepithelial lymphocytes, which are of course a different category of cell type, which shouldn't be identified. I might have accidentally slightly overset the sensitivity. I will drop it. This should be an optimal compromise. I think it is. And we can see now in real time, as I pan through the image, segmentation of the foreground tumor from the background stroma, avoiding the tumor infiltrating lymphocytes, which is of course part of the process of ideally generating ground truth maps that are only the cancer and not additional cell types. Again, some tumor infiltrating lymphocytes that have not been called out, again showing the utility and speed with which classification of foreground versus background can be carried out. One final example, we'll look at diabetic nephropathy, characteristic Kimmelstein-Wilson lesions of diabetes. These are glomeruli, of course, and we can see the characteristic lesions. If we want to make a classifier that will find all the lesions, it's really as straightforward as picking perhaps one area, generating again spatially a classifier, clean that up a bit, and of course these areas can be edited for optimal specificity, and then running the classifier in real time. This will probably be too sensitive. That can be compensated by adjusting the sensitivity. Slightly less sensitivity than desired. 34 should be optimal. And we find that it is. And at this point, with a single converged vector, we can identify throughout the entire section all portions of glomeruli that have characteristic KW lesions. This type of exercise carried out on the part of a subject matter expert would take significantly more effort. If we're looking for a more specific submorphology, for example, we can use this particular glomerulus as the training vector, picking a larger area, which will yield even more specific results. And we would expect this to be identified, and it was. And of course, this algorithm, which makes use of a set of GPUs in the cloud, literally carries out the segmentation in real time as the image is being perused and then transported across the web. So the transport layer sends both the tiled original whole slide images along with a heat map of the output of the VIPR algorithm. This concludes this demonstration of the VIPR algorithm as developed at the University of Michigan Division of Pathology Informatics in the Department of Pathology.